Welcome to Mr. Hannon's very special guest bedroom where his um, very special setup for this video is occurring. I just wanted to give you a couple examples of the disk method, and here's three of them up here. The first one is 4 minus x squared, and we're just going to rotate that. Do you see the red circle there? That's letting you know what we're rotating around. On the next one, I say that I want you to rotate the first crest of sine of x about the x-axis. So I'm saying it in words. And in the last one, I'm saying it in words and with a range that's there. So I took a second to draw the little circles on there to show you what it's rotating around. That symbol right there means, hey, we're going to rotate around that line right there specifically. I also like to draw in a little rectangle just to show, hey, what am I moving around? When I take this rectangle and rotate it, it's going to form a disk. And the volume of that disk is pi r squared times the height, or dx, the width in this case. Now the disk is going to look a little different down here because of the shapes that that's in, but the important thing here is you need to figure out what is the radius of each of these. What is the radius? Take a second and try and figure out what would be the radius in each one of these drawings. Now finding the radius of each of these, really, if you draw a little rectangle on there to represent what it's going to do, it's going to rotate around and form a disk there. If you can get that rectangle drawn in correctly, you'll notice that radius is the length of the rectangle in each case. And in the first two, that is just equal to the function itself. Now, the radius for y values there, that's going to be a little bit different because now you see it's the distance from the y-axis over to the function itself. How do we get the width of that? Notice our function actually shows us how to get the height. The y value is the height. The width is the x value. So what we do is we rewrite this equation in terms of x. X will give you the width, x will give you the radius. And besides, our y values were the limits anyhow. So when we're writing this last one, you can write it all in terms of y. I'll just write up the functions. And in each of those cases in orange, you can see what the equation is for the disk method. The same thing as the volume of a disk or a cylinder. And you'll notice the units are the x coordinates, 0 to 2, 0 to pi, except for down here in the last one. Since this is in terms of y, we're now going to look at the y values. We go from 0 to 4. And then all you need to do is plug in the radius to each of those. And you actually have the setup for all three problems. Integration could be a challenge, but it depends on the problem, and a lot of times it's not that bad. There are different methods, and you can also use a calculator on many problems. Let's try just a few more. So I'm just going to use this same sine example for some different things that we might rotate it about. For instance, on the first one, we rotate about the x-axis, and that's the answer that we had already received. What if we change the axis of symmetry, like to y equals -3? And we're still going to take this from 0 to pi. So we're still taking that loop, but now we have to rotate around something much farther down. What would happen to your radius here? Would it change? Would it be different? Of course it would. What do you think that radius would be? Well, we have a rectangle there that we're going to rotate around that axis. So now you can see the rectangle. If you rotate it, you get a disk. It has a thickness of dx. The radius is the length of that rectangle. And to get the length, you take the top part of that rectangle minus the bottom, and it will tell you the length of it. So when the top function is sine and the bottom is -3, you subtract them. And by the way, subtracting a negative will make that plus. Now it's easy to come up with our equation for the disk method for the volume of this. And you have the setup, which is all we need to work on right now. So the final example is what happens if that axis is way above it. When we rotate this around y equals 10, you're going to get a much different shape. This is going to rotate up above it. It's going to be much bigger and a completely different look. But to get the radius, we do the same thing, top minus bottom. The length of the radius is top minus bottom. Plug it in.